Hey guys, welcome back to Adam's Workshop. Sorry, I know I've been out for a while. Won't bore you with the details as why, other than at this point I have a minor injury that is keeping me from going out working on cars. It's kind of hard to stay on my feet for any length of time poking around under a hood. With that said, I thought, what can I show inside? And I figured I'd show you a couple new toys that I got. Let you know what I think of them. They are all from the same brand, and yes, I purchased them all off Amazon. I'm going to start with this one right here. This is, not sure if I'm saying the name right. Let's see here. Get that a little brighter. This is the Kaiweets PS-3010F, and it is a variable DC power supply. Decent size. It's not as thin. I know a lot of them are a lot narrower than this one. I didn't want that. This one weighs 5.9 pounds, so basically 6 pounds. Let's see, I got a couple things written down. I do want to make sure I tell you. Okay, what does it put out? Output voltage. Puts 0 to 30 volts, 0 to 10 amps, and it also shows you the wattage. It has a large LED display for each of them. It has, you can see CC and CV. It has where you can set it for constant current and constant voltage. Has a 5 volt, 2 amp USB interface. Nice big power button. Did I just knock you out of view there? Alright, there we go. Nice big power button. You can see here's your negative, your ground, and your positive wire. You can disconnect this right here that connects the two if you want a floating ground. I personally like doing that. I feel it's a little safer. That way I'm not hooked up to mains ground. Correct me if I misspoke that. I believe that's how I understand to work. Anyway, what else do we have? Protections. It states that it has a limit current protection, thermal protection, voltage overload protection, and short circuit protection. It does show on the back a safety certificate conforming to ROHS and CE standards. Right here. Yes, it is made in China. Okay, while we're back here, I'll point out the fan. One thing I do like about the fan, it is temperature controlled, so it is not running continuously. I like that. You see it's all vented on each side, so with the fan in the back, it's going to, one would think it's going to keep everything nice and cool in there. I did peek through these. I did not open it up. I'm trying to zoom out. I did not open it up, but I did peek through these vents with the flashlight, and all the soldering points do look like they were done good, so I had confidence in it. I've seen a lot of good reviews. I read all the reviews on Amazon, everywhere else I can find them. Most people spoke good of it. Watched everything on YouTube. Everybody seemed to have good things to say about it. What does it come with? It comes with the power supply. Comes with a power cord, which I have hooked in, so I'm not going to go unplugging it. It's just a power cord. And comes with these right here. BNC to alligator clips. I do like this with the BNC here, where it has the little holes. That way when you're plugged in, you can probe right there with another probe, should you choose to. I believe that's everything that it came with. If I notice anything different, I'll tell you. It might have come with some leads like this. I'm not positive. I've got so many different lead sets. I don't remember what came with what. Oh, I do want to mention on the back here. Here's your power supply. The fuse. How easy is it changes fuse? Check this out. Just get right here. Look at that. Comes right out. Bam. Don't have to open the whole thing up. Comes right out. 250 volt fuse. And this just pops right off of there. Like so. Simple as that. Man, don't you wish everything else was that easy? Yeah, so that gets a thumbs up in my book for sure. And then you can see it just slips. I'm trying to do this while looking through the camera, so bear with me. It just slips right through and snaps right on. Alright, let's hook it up and see what this baby can do. Alright. Owner's manual. Does come with the owner's manual. Oh, I forgot to mention 3-year warranty, and it states 36-month after sales service and lifetime technical support. Do I think they'll honor it? You bet your ass, and let me tell you why. This is kind of part of the reason why I'm making this video here. Just real quick off the subject, I purchased this here. This is a Kaiweets also. This was the first one I purchased from these guys. And let me turn that brightness down a little. There we go. This is the first one I purchased from these guys. Kaiweets multimeter. Alright. See if you can see the model number. HT118 Alpha. Anyway, you can see all the different options you have on it. This is what I purchased. I saw it. I liked it. I did not need another multimeter, but just, you know, browsing through, I liked it, threw it on my little wish list, and on Prime Day, it knocked it down for, I think it was originally selling for 35, 36 bucks. Prime Day gave it a lightning deal for, I want to say 22 or 25 bucks. These are not the leads I came with. These are some ProMaster leads that I'll maybe make another video about at another time. I believe it came with these leads right here. And anyway, this is an awesome little meter. So I bought this, and almost immediately afterwards, I bought the power supply. Once the power supply came in, I wanted to play with it. I was playing around with it with this one here. And long story short, I blew a fuse. Pulled the fuse out. Saw what kind it was, ceramic fuse. Started looking everywhere, and I could not find the exact fuse that went in there. So I contacted Kaiweets by email, told them that I blew the fuse. How do I get a fuse to remedy this issue? To be completely upfront, I did mention to them that I have a small YouTube channel, and that since I like the meter so much, which this is true, that I wanted to make, that I was going to make a video with it. And before I made the video, I blew the fuse. So how do I remedy this issue? Can you send me a fuse? Guys, this is how they fix the issue. They told me their warranty that I read off earlier, 3-month warranty. Not only, they did not send me another fuse, what they sent me was an entirely new meter. Same exact one. Told me to keep this other one. I mean, how freaking awesome is that? Sent me an entirely new meter. They could have just sent me a fuse. This case I did purchase separately on Amazon. I think it was about 15 bucks. Really nice case. It's pretty solid. Soft on the inside. I do have the owner's manual stuffed in there. Anyway, so they sent me a whole nother meter. And check this out. On top of sending me a replacement meter for the blown fuse, they sent me this meter here. Now this one did come with the case. Alright. This pretty neat. I'll make a separate video about it. Really neat little meter, but just to give you a little sample of a future video, this is a smart meter by them, by Kaiweets. Just give you a quick little sample. really neat, guys. It's a smart meter, so basically for voltage, ohms, and continuity, once you hook your leads up, you don't have to choose. Once you connect it to a circuit, it's going to choose one of those three, whatever it senses. Or you can go to manual mode for all the other settings. Anyway, that's a whole nother video. I just wanted to show you, this is kind of why I really wanted to show you guys this. One, I did like this meter to begin with. But you know, a lot of times people are eerie about getting stuff from China. About, you know, how's the warranty going to go? Well, that's how it went for me, and I wanted to share that with you guys in case anybody's thinking about getting any of these products. Rest assured, they are going to honor their warranty, and they're going to go above and beyond. You know, after sales problems is one of the most important things for me. Look, I'm alright. I'm already 11 minutes into this video. I'm gonna have to cut this down. Alright, to the power supply. Oh, the meters that did. Never mind. I'll show you all that meter later. Right. Power supply. You have two choices. You can do the constant voltage or constant current. I do want to just real quick, I want to show you guys real quick. I just want to show y'all guys the specs here. Okay. I'm not going to read everything off. You can pause the screen and read it if you want. I know I'm a little shaky. I need to eat something. My blood sugar's off a little bit. So there you have that. Alright, so constant voltage gives you your steps right here, what you want to do. Or you can go to the pictures. It has these steps here, or you can go to the pictures here and tells you what to do, which is pretty simple. Pretty simple. So what you're going to do, have it turned off, you're going to turn everything all the way down counterclockwise, all four of these counterclockwise, and turn the supply on, and then you're going to turn your current, your course current, all the way up, all the way clockwise, and then you're going to adjust your voltage to wherever you want to adjust your voltage. We'll start at, say, 1 volt. There you go. We'll start at 1 volt. Tells you to set it where you want, then turn it off, then connect it. So what I'm going to do is, since if you watch my channel, you know how I feel about the Micsig Oscilloscope. Absolutely love it. I trust it. So I'm going to use it. Well, how do I connect it into the power supply since it's BNC? I ordered this bad little boy right here from Pomona, and it is BNC female, or I'm sorry, yeah, BNC female to 4mm banana. So I'm going to just connect these right here. And we'll connect this right here like so. Red into red, black into the black. Connect it, and then on she goes. Now, what channel are we on here? Channel 4. We'll get rid of channel 3 at the moment. Check out some cursors. Alright, we're going to put cursor number 1. I'm going to zoom y'all here in here in a second. We're going to set cursor number 1 right on the ground line, on the 0 line. Oh. What the heck? I'm at a bad angle here. There we go. And then cursor number 2. I'm going to put it on the line that it's measuring. And we're right at 1 volt. So instead of putting y'all guys on here, I'm going to try and set you up on this bigger camera or screen here. I think if I can get it just right, try and set y'all where y'all can see the screen as well as the power supply the best I can. And right now we're not doing current, so you really only need to see the top one, yeah? And you know what, I really don't like that. Oh guys, y'all are gonna have to kind of, I can't zoom into both of them, so I guess first I'll just have them both on here and we'll look at the difference. Let's see, I'll move this up to wherever it stops. 7.64 volts. We'll move our cursor. Move our cursor up here. And there we go, 7.6 volts. I want you guys to see. If you notice here, can y'all see that? The top one is 0, that's our ground line. The second one, 7.6 volts, and the third one is the difference between the two. Okay. Also, on the bottom, I'm hoping this is going to be bigger on a screen than what I'm seeing on the iPhone. On the bottom, you can see the mean, RMS, min, max, and a peak-to-peak setup. So you can see also we're showing 7.5 on all of those. All right, let's jump up a little more wherever it stops. 14.11. Now keep in mind, I'm just using the coarse, but if I want, I can use the fine one. If I wanted to go to like 4.15, you know, it is a little touchy. There you go, 4.15. Notice on the screen for the scope, we'll bring up our measuring line. And 14, let's see, if I'm right there on 14.10, if I go up one, I'm 14.20. Both of them are in that line, so, but what we can do is look on the bottom there at the mean and RMS, and it's showing 14.10. Let's see, you know, another thing I can do is I can incorporate this other meter right here. Let's see, I can get this guy in the game here. Move my magnifying glass. And let's see. Untangle my wires. Guys, I'm a perfectionist. I have to have everything perfect. It's just my personality, you know. All right. So what's cool right here with the Panoma leads, just like the ones that came with this, you have where you could probe right there, but then you can also plug B and C right into the back right there. Or in this case, what I'm going to do is I'm going to use these alligator clips. I'm going to connect like so on each one. Make sure this is plugged in. Turn on our meter. Go to volts. I like this meter because I work in automotive, and when you turn it on, when you turn on the volts, because it is auto ranging, it goes directly to DC. You see that? It goes directly to DC. So if I want AC, I hit the function button. Then it gives me the AC, but it also gives me the frequency up here. You can see where it shows the hertz if I was doing alternating current. But I do like, because a lot of meters I've noticed go straight to DC, and since I'm always having to press the function button to go to DC. They become AC. Anyway, just something I want to point out. So here we go. Look on the screen. 14.15, 14.16. I think it's kind of funny because they're both the same brand. So now they are showing. I do love my Micsig, but I have to show what it's showing here. If you look in the background there, I'm trying to get all three on at the same time. You look in the background on the Micsig, it's showing 14.10. We're putting out 14.15. This one's showing 14.16, 14.10. Maybe these are closer together because they're the same brand. I don't know. But I mean, that's going down to the next decimal. You know, 14.1, 14.1, 14.1. I mean, do we want them all exactly perfect? Of course we do. It is what it is. I'm just showing you guys what it's doing. All right, we'll jump up a little more. Stops at 1705, 1705. And what do we got? 17.10. And if you look on the bottom lines, it's showing 17 exactly. So I'm good with that. You know, would I prefer that the second digit here be identical like it is here? I love that those two are the same. I wish it was on here as well. You know, which one's actually right? You know, is this one right or is that one right? How do we know? I don't know. Throw in another meter, I guess, right? Throw a tiebreaker in here. Let's do that. All right. I'll add in this Innova. I'll wipe that screen off a little bit. It's an Innova 3320. Man, I used this thing forever. I've diagnosed so many cars using this guy. I lost the little back piece. Oh yeah, and on the back here, I have on some of my other meters, you can see the diode output, 1.58 volts. Because you can use that to test your circuit integrity. If you didn't know that, look it up. I'm sure you can find something on it. Alright, so we'll go to DC volts. Let's set this guy up right here. And we'll see, we'll try and hook this one in. Alright, what do we got? Okay, so that's interesting. This one doesn't have a light, I don't think. If it does, the fuse is blown. I loaned that to my younger brother and he blew the fuse. Alright, so that's interesting. Tiebreaker is showing 1703, which takes us closer to the Micsig 17 even. I don't know, you guys just, I guess, take it for what it's worth, you know. We'll jump up some more. Remember, we can go up to 30 volts. 21.57. Here, 21.5. Here, 21.58. And let's go on the screen here. Raise this up. We are at 21.60. 21.6. Oh, y'all can't see that. Alright, so I wish y'all could see that closer. There we go. 21.6. You can see I'm using, I know, I'm a terrible cameraman. Using my meter. I just turned the wrong button. Let's put that 1 second per division. Oh, and I've got, just so y'all know what's going on here, I've got 5 volts. Five volts per division on my vertical, and I've got 1 second per division on my time base. And, alright, here we go. So you can see there's my cursor for my measurement. Remember, we are at, wires caught on my tripod. We're at 21.58. We're showing 21.5, 21.59, and on this one, 21.6. But with that said, I want y'all to notice when I move my cursor here. Alright, I'm going to zoom in because I want y'all to see this here. Like, I want y'all to see the measurement. As soon as I get into it, I'm into it right there. But look, I can still go down 1, 2, 3, 4 times before it pops out the bottom. So which one is the right one? You know, we're looking for 21.58. I think it's 21.6, and the reason I say that is because the bottom is showing 21.6 on your mean, RMS, min. How far into it am I on that setting? Let's see. Alright, so we're going to start at the top. As soon as we're in it, 1, 2, 3, 4. So 4 from the top. If I come into the bottom, as soon as I'm in it, 1, 2. It's the second one. Just in case any of y'all Micsig owners are curious about that. Alright, shit, we're already at almost 30 minutes. Alright, I'm going to hurry up here, guys. I want to get the voltage in on this video, and then I'll make a second, quicker video, since we won't need the induction of all the everything I did at the beginning of this video. The second video will be straight to current, and we'll use something for a load, a light or something. Alright, we'll take another jump. 25.98. We have 25.8 on the Innova, 25.99 on the Kaiweets. Who thinks I'm saying that right? Kaiweets? Kaiweets? I don't know. Alright, let's jump up here. And let's get our measurement cursor. And we'll get it up here. Whoa, 25.99. There we go. Okay. Oh, look at that. Wow. Okay, so that's I don't like that. Look at that, guys. I'm not sure about that. I'm showing 26.10. 26.10 on the Micsig. I'm almost tested to break out the other Micsig. You know, I'm going to do that, guys. I'm going to pause this. Be right back. Alright, guys. First of all, while I was setting up the ATO, we've been using the STO 1104E. I went ahead and grabbed the ATO 1104. And I opened the menu on the STO because I wanted to get the same, set the ATO up the same. And I noticed that I was on a low pass filter. And if you look here, now remember, we're set up, we're at 26 volts. Now actually it was 25, now it was 25.95. Darn it. I didn't touch this until right now. Darn it. Anyway, it was 25.95, remember? And on the Micsig, we were showing 26 volts. Okay? Well, I noticed, man, that's kind of hard to see if I can get that in better here. That's a little better, huh? Okay, so we were showing 26 volts. I realized we were on a low pass filter. So I hit full filter. We were still showing 26. Okay, this number is a little different. It was like showing 26 even or 26.01. I have to make that darker so you can see the numbers. So anyway, I hit 20M, and when I hit 20M, put us right on the money, 25.9. Okay, so it's really all in your settings, you know, to get that perfect number. Because I knew the oscilloscope is obviously it's going to be closer of a measurement than a multimeter. It just makes sense. Here on the ATO, it's the same thing. Right now, we're on the money, 25.9. Why is that only showing? Huh, I never realized that before. Look at that. I'm missing a digit here. 25.9 on the ATO. Where's the STO? I pick up that other one, 25.90. I'll be damned. I wonder if that changes with my settings. See, if I hit low pass, it went up to 26. And on the power supply, we're showing 25 point, it's bouncing back between 25.95 and 94. You see, if I hit the low pass, it's showing us at 26. Whereas if I hit here, 100M puts us on the money, 25.9. And back to the other ones, 25.6, 25.8 on the Innova, on the Kaiweets, 25.95. So there you have it, folks. Yeah, I was getting concerned. Y'all know how much, if y'all watch my channel, y'all know how much I love my Micsig. And I was getting a little nervous that it wasn't reading right. But that was on me. Nope. Yeah. I'm having trouble with my tripod here. I'm using an iPhone and I have it connected to the tripod using a zip tie. On that note, I had made these videos previously and made every one of them. Long story short, my phone did not have enough memory to post them from my editing app, the iMovie editing app, to my phone or YouTube. It kept saying not enough storage in my phone. Guys, I deleted 12 apps, 500 and something pictures, and so many videos, and it said I still didn't have enough. So I spent a week or so shopping for cameras. I was looking at GoPros, not want to be much over 200, so it was a low-end GoPro, all these other, you know, camcorders and stuff. But all the roughly in that price range camcorders, the cameras, the video looked like it was video from an iPhone from like the early 2000s. It was crappy, all megapixel. The GoPro was the best one, but you can't zoom in. I have to be able to zoom in on these videos so you guys can see everything. And I remedied it because my daughter got a new phone. She had this iPhone 7 that I have right here I'm recording with, and she got a new one, so she'd factory reset this one, and we deleted all the apps except for what's necessary for me to make these videos. And now I have like 25 gigabytes of storage. So thank you, Jade. That's my daughter, Jade. Jade. However, the phone is rose gold, so it's like an off pink, and it has a pink flowery case on it. So yeah, go flowers, go pink. There's a bunch of unnecessary information. I'll probably edit it out. Let's finish up real quick. Just finish this up real quick. All right, 25. We're gonna jump up to, let's go to the max. So my coarse, I'm all the way up at 30, 24, and then if I turn my fine one, or what do they call it? Yeah, fine. Turn it all the way up. It says output 0 to 30 volts, but it actually takes you to 32.02 volts. On the Innova, we see 31.5. On the Kaiweets, 3203. And on the Micsig, let's see, where are we? Let's get, keep moving the wrong ones. Alright, finally, we'll get up there. And we're looking for 3202. Wow, 32.20. Huh, just when I thought I had it figured out. 32.20. Uh-oh. Something's wanting to turn off. 32.20. I don't know, guys. This video is so long anyway. So there you have it. There is the Kaiweets variable DC power supply. What do you guys think? Where's that light coming from? What do you guys think of it? I think it's it does what I need it to do. My main reason for getting it, well, one, I just, I love tinkering with electricity and stuff, using it to fix stuff. You can use it if you need to for automotive, which would, you'd have to bring it outside and bring an extension cord or whatnot. But I'm looking into getting the Alegu, which is similar to the Arduino. I'm not sure how you say that, Arduino. And well, the Alegu, if y'all are familiar with it, it's basically building your own circuits. They have numerous projects. So I'm looking at getting one of those, and I wanted a output power supply. Like I said, I like fidgeting and stuff. I like playing around with little circuits, my own little circuits and stuff. And up until I got this, I've been using a jump box, which sucks because I'm limited to whatever it's at, 12.6 volts, whatever. I do have a Power Probe 4 with the reducer. It brings it down to 5 volts, so I was able to use that to put out 5 volts. But that was it. I had 12 volts or 5 volts. And I looked up these, and this is the price range. I didn't want to go up much over $100. Sure, there are some more expensive ones for like $300-400 that I'd love to have, and maybe someday I will. But for right now, I wanted to be around $100, and after a few weeks or more, actually longer than that, of research, this I believe was the best option. You guys see it seems to work. Between the oscilloscope and the two multimeters, everything was right in line as far as what it says it was putting out is what it was putting out. I like the color. It is a good looking supply, bright LED. Also, like I said, I didn't use it, but it has a USB, so if I wanted to charge my phone, I could easily show you. Easily just plug in right here. And I need to eat, pretty shaky. Plug in right there, and then I could just look, see if y'all see. You should notice up on the top here. Look, I'm at 100% right now. I just charged it, but look, I'm gonna plug it in, and y'all should see right there. Boom. 100% charged, and it does have the little lightning bolt. Man, it just doesn't want to show that. It does have the little lightning bolt inside the battery, so it is charging. What else? So on the next video, I'm going to be showing the current output on the power supply. I'll be showing the current output, and I may want to use the current clamp. This is my Micsig CP2100B, that is Bravo. If you're familiar with the Micsig current clamp, it does not have a battery. It is powered by USB, so it's powered by, in my case, if I'm using it with one of the Micsig oscilloscopes, you plug it into the USB plug for the oscilloscope. But say I'm using that Panoma attachment that converts me from BNC to banana jacks, and I'm using this with a multimeter, I could plug, I'm still going to need power, so I can plug my USB right into the USB plug off the power supply to get my power for it. So y'all get the picture, y'all get the idea. I think it's a good power supply. What don't I like about it? There's really not much that I can think of that I don't like. It is a little finicky on getting like exactly where you want. You know, let's say I want to be right at, you know, say I want to, let me just knock it to something. Say I want to be at 3.25. You know, you have the course to get you, you know, so close. See, this is what I'm talking about. This is what I don't like. So look, okay, so I could stop there. Okay, I got close there with the course, and then I get the fine. And then here, now this one doesn't jump around as much, so it's a little easier. And I can get it right at the 2.25. Did I say 3.25? Whatever. 2.25. I think I'm still not there. That's, I guess, my biggest drawback of it. Is that a major problem? No. And not to mention, I'm using my left hand right there because I'm trying to work around this camera. So when I'm working without the camera, yes, I can go quicker than that. But that's probably my biggest drawback is, you know, it does take a second to get into an exact fine measurement if that's what you're looking to do. I really can't think of anything else. If I do, I will mention it in the next video. Like I said, coming up next is going to be the same power supply, but we're going to be testing current on a load, probably a light bulb. Alright guys, thanks for tuning in. Hope you liked the video. Sorry it's a little long. We'll see you on the next one.